we are going to talk about prime and composite numbers. So I've taken a moment and written out the definition for composite numbers for you. And composite numbers are positive whole numbers other than the number 1 having more than 2 factors. So you may or may not remember when we went through and we talked about the greatest common factor. And we used that to help us simplify fractions. Well, that same information is going to help us decide if a number is prime or composite. Remember that a composite number has more than 2 factors. A prime number has only 1 in itself as a factor. 14 is a composite number because 14 has factors of 1, 2, 7, and 14. 1 times 14 is 14, and 2 times 7 is 14. Remember that these numbers, when we went in and learned about multiplication, are called factors. Factors are numbers that are multiplied together to get a product. Multiplied together to get a product. So 14 is a composite number, but 7 is a prime number. The reason that 7 is prime is because it only has 2 factors, 1 in itself. We can demonstrate this really well on a hundreds chart. Okay? When we look at a hundreds chart, we can figure out what numbers are prime and what numbers are composite. And the first thing that we want to do is we want to start with our first row. So we start with 1. 1 is neither prime nor composite, so it doesn't even really count. 2. 2 only has 2 factors, 1 and itself, so 2 is a prime number. 3 only has 2 factors, 1 and itself, so 3 is a prime number. Now 2 and 3 can be factors of other numbers, but they only have 1 in themselves that can be multiplied together to reach that number. With 4, we have 1 times 4, but we also have 2 times 2. So 4 is going to be a composite number. 5 has only 1 in itself. 6 has 1 times 6, but it also has 2 times 3. 7 has 1 in itself, and that's it. 8 has 1 in itself and 2 times 4. 9 has 1 in itself and 3 times 3. And 10 has 1 in itself and 2 times 5. So when we get through the first 10 numbers, then we begin to look for patterns. So the first pattern we're going to look at is things that have 2 as a factor. So anytime we count by 2s, if we hit an even number other than 2 itself, that is going to be a composite number because now we said 4 has more factors. It has 1 in itself and it has 2 in something else. Same with 6. Same with 8. Same with 10, and we keep on going. Now what we can say about this is that all even numbers except 2, all even numbers except 2 are composite. And remember, a composite number has more than two factors, more than just one in itself. All right, so while you are filling yours out, I'm going to go ahead and pause mine and fill mine out. You can either wait until I'm completed and pause it after so that you have the model, or you can fill yours out and then just use mine to double check. Either way is fine, but I don't want to take up too much of your time, so I'm going to go ahead and pause this. All right, so we've knocked 2's out of the way. The next thing we can say is that all numbers ending in a 5 or a 0 except the number 5, so anything greater than 5 that ends in a 5 or a 0 is a composite number. The reason for that is anything that ends with a 5 or a 0 is divisible by 5, which means that 5 is one of its factors. So all multiples of 5 not including 5 are composite numbers. And what we'll see is this, with the numbers that end in 0, not only are they divisible by 5 and have 5 as a factor, they're also divisible by 10. So all multiples of 5, not including 5, are composite. All numbers with a 0 in the ones place, except 0, are composite as well. So now I'm going to color in our 5's, and I'm going to go back over our 10's with another color. So I'm going to do our 5's in pink, and remember 5 is a prime number because it only has 1 in itself, so we don't include 5 on that one. And all of these that end in a 5 and all the ones that end in a 0 are composite numbers. I'm going to go ahead and pause it and let you color in. Okay, I went ahead and colored my 5's in. I went ahead and colored my 10's in with my pink, but then you'll see I went over it with purple just to show that all of these numbers have 10 as a factor as well. So just keep in mind that 5 goes into both of these columns and 10 goes into this, 10's go into this column. So 10 is a factor here, 5 is a factor for both. All right, now does that mean that we're done? No. We still have factors of 3 that are not colored in. We have factors of 4. I think they're all colored in because there are also factors of 2. We need to color in factors of 6, 7, 8, and 9. So let's start with 3's. 3 for sure we know is a prime number. But when we count by 3's, we say 3, 6, 9, 12, and again, some of these are overlapping, 15, 18, 21. Oh, there's one that wasn't colored in before. 24, 27, and we're going to go all the way through. Here's 30. We're going to go all the way through the 100s, counting by 3's. If you're not sure quite how to do that, just go like this. 1, 2, 3, color it in. 1, 2, 3, color it in, if that helps you. All right, I'm going to go ahead and pause mine while I go color in all of the ones that have 3 as a factor. All right, so we see that there were some more numbers that had not been colored in that did get colored in when we counted by 3s. Now, as we continue on, we have to look at 4s. So 4 itself is 1, 8, 12, 16, 20, 24, 28, 30. 28, 32, 36, 40, 44, 48, 52. So far I'm looking through these and all of them are colored in. 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, and 100. Those are all already colored in, so I don't need to go back over those. We talked about 5s already, so let's do 6s. We have 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, 78, 84, 90, 96. All of those are already colored in. And so now let's look at 7s. 7, 14, 21, 28, 35, 42, 49. So 49 is one we needed to color in. And then it's 56, 63, 70. 77 is one that needed to be colored in. Okay. 84, 91, is that right? 84, 1, 2, 3, 4, 5, 6, 7, 91. And 98. So those are all colored in. Now we have to do our 8s, and I'm going back to pink again. So let's do 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. Those are all colored in. So that's the 8s. Now we look at the 9s. So with the 9s, we have 9, 18, 27, 36, 40. Look, here it is all the way down. 81, 90, 99. So those are all colored in as well. And then we colored in our 10s. We might want to look and see if there's anything where there are double digits like 88, 77. Those are all colored in. Those are divisible by 11 for sure, even though 11 is prime. So what we're left with when we do this is everything else that's on here should be a prime number. That means that all the numbers that are left on here only have 2 factors, 1 and themselves. So when we list the prime numbers from 1 to 100, we start with 2. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47, 53 and 59, 61, 67, 71, 73, 79, 83, 89, and 97. These are all of the prime numbers between 1 and 100. These are all of the prime numbers between 1 and 100. I would encourage you to go ahead and memorize those, just because you will see prime and composite quite frequently from here on out.